using an example, explain a non-Gaussian distribution. So in order to understand this, let's look at what a non-Gaussian distribution is. So first of all, it does not follow any properties, of a normal distribution. So generally a normal distribution has mean, median, mode as same. So that's completely opposite here. So the mean, median and mode are not same here. The mean, median and mode are not same. Or you could say they are different. So a non-Gaussian distribution is generally asymmetric in nature. It is asymmetric in nature. That means if you split the distribution, it will not be in a two equal parts. So yes, and even this is opposite of your normal distribution, where in a normal distribution, it's symmetric in nature. It's symmetric about the point mean. So even that is different here, and it does not have a bell curve. It does not have a bell curve because of distortion in data distribution. Because of distortion in data distribution. So this is caused generally due to skewness in data. So the distortion is in the form of skewness. Okay. So we can also call this as skewness. And now let's look at an example and see how a non-Gaussian distribution is different from a normal distribution. So I'm going to draw a graph here representing both the distribution. I'm going to use two different colors in order to represent them. So let's draw the normal distribution first. So obviously a normal distribution has a bell curve, and it's symmetric about the mean. So let's draw the mean. Obviously for a normal distribution, the mean, median, mode is same, but generally we consider mean as the correct representation of the data. So this is the mean. Now let's draw the non-Gaussian distribution. So obviously a non-Gaussian distribution does not have a bell curve. So it will have some sort of distortion. So obviously it's not a bell curve, right? And it's skewed. It has skewness, or we call it as distortion in the data. So the blue line represents a non-Gaussian distribution and the red line represents a normal distribution. So this is how a non-Gaussian distribution is different from a normal distribution.